Good morning, good afternoon, good evening, drone pilots, wherever you are, whenever you are. Today, I'll be teaching you how to connect your drone to the internet using a Raspberry Pi. We'll be going over, the assumption is you've already installed Raspberry Pi operating system and can SSH into the Pi. We'll be going over the software you have to install onto the Raspberry Pi and the hardware that you have to use to connect it to the drone. So as usual, we have a set of instructions on the course website under Files, Advanced Topics, Internet Connected Drones, how to connect your drone to the internet using a Raspberry Pi. There it is. So we mentioned the prerequisites. The ArduPilot instructions for reference are here. So the very first thing we have to do is configure the Raspberry Pi software. So we have to SSH into the Pi, which we have set up before. Now we want to disable the Bluetooth since it may interfere with the serial port. It was not necessary. It was necessary to do this for the Pi Zero version 1. I don't know if it's necessary for version 2, but I did it anyway. So I have to edit this text file. Copy, paste. And we go all the way down to the bottom. Uh-oh. Right. We'll get to that in a minute. Okay, so we want to add this line, DT overlay, disable Bluetooth. Control X, save yes, file name right, yes. And just for good measure, let's reboot it now. Again, boot time is about 30 seconds. So the next thing we have to do is enable the serial port, because that's how we're going to be communicating with the flight controller through the serial port, the UART. So that's done with the Raspberry Pi configuration menu, which pictures are down here. So I'll walk you through it in the video. So spend 30 seconds. And there we go. So we want to run sudo raspi config. That brings up this menu. We want to go to interface options, serial port. Would we be able to log in shell over serial? No, we're not doing shell. We're going to do MAVLink. Would we like the serial port hardware to be able? Yes. Okay. Finish. Would you like to reboot now? Yes. So another 30 seconds for the reboot. While that reboots, we'll figure out what we're going to do next. So the next thing we need to do is install a program called MAVLink Router. It does exactly what it says. It takes MAVLink packages from a flight controller and passes them to the internet IP address you specify, and vice versa. The GitHub home for MAVLink Router is here, and I've made my own install script to make the process less painful, and I'll show you that install script here. So it's install.sh, and let's make this a little bigger, and let's go to Chrome. Also like better. So let's make that a little bigger. Okay, so basically we do an update and then we install git Meson ninja build package config gcc g++ systemd, and that allows us to compile. Then we clone the MAVLink router repository, and then we build it. This is the compile code. telling it to compile it. Then it actually compiles it on our Raspberry Pi for us. Then we have to download a file called main.conf, and that's a configuration file. I've set it up for you. So we download that to our Raspberry Pi, and that's what MAVLink router uses to decide where it's going to route points from and to. And then we enable MAVLink router as a service. So that's what the install script does. And on the GitHub repo, there are directions of how to run it. So we get the script. So let's see if we can get back in. So we wget that install script, and then we make it executable and run it. Now this typically takes about 10 to 15 minutes, so I'll speed it up in the YouTube video. Okay, so that is done. We just installed MAVLink router. Okay, there was a small glitch in the matrix there and the video stopped recording, so we'll continue from where it stopped. So if I have the timestamp correctly, we just finished installing MAVLink router on the Raspberry Pi, and it got compiled and everything. So now we want to, just for educational purposes, look at the main.conf file that was downloaded and what it does and how we might want to edit in the future. So this is the install script. We'll look at that in a minute. This is the main.conf file that was downloaded from GitHub onto our Raspberry Pi. So let's see where it went and look at it in a color-coded editor. It went into etc MAVLink router main.conf. So let's just look at that on the Raspberry Pi. So we're just going to nano it, the editor. Okay, so the white is what is important. The blue is commented out. So we are serving up MAVLink traffic on server port 5678. Any TCP connection to this Raspberry Pi on that port will be getting and will be able to get and send MAVLink traffic from and to that port. And then the UART is the serial port. There's only one on the Raspberry Pi. It's called serial 0. And we have set it to baud rate 57600 because that seems to work for me. You can try other bauds, but that seems to work for me. Make sure you have that baud correctly set on the main.conf file and on the mission planner connection and also on the settings of the ArduPilot. So that's our next task. So we just finished this install of MAVLink router. Now the next thing is to configure the Raspberry Pi hardware. So the Raspberry Pi is going to get 5 volts in ground from the drone somehow. You could use a separate battery eliminator circuit back. What we're going to do is get it from the flight controller. So the flight controller has a BEC on board. We can look at the data sheet for it. And of course it opens up in Edge. I want it in Chrome. So here's the flight controller data sheet. And you'll notice it says dual BEC, 5 volts, 1.5 amp, and VX 5 amp. Oh, I thought it was a 2 amp back. Let's see what the specs say. Back 5 volt, 1.5 amp. Okay. Now on the layout here, it says 5 volts, onboard back 5 volts, 1.5 amp continuous max 2 amp. 5 volts is not supplied when using USB only. 4V5 means 4.4 to 4.8 volt max 800 milliamps. So do not use the 4.5 volt pin like this one right here. And I'm going to explain why when we talk about the Raspberry Pi. The Raspberry Pi 02W needs a 2.5 amp power supply according to the specs. But I've seen on blogs it only uses about 600 milliamps typically. So we're going to use the onboard BEC that has 2 amp max available on the pins marked 5 volt. Do not use the pins marked 4.5 volts. They can only do 800 milliamps. That's a typo. So which UART will we use from the flight controller when we wire it up? We're already using UART 5 for the GPS. We're already using UART 2 for the radio. So that leaves UART 1 and UART 4 as options. UART 1 has a 5 volt near it, so we will use that. And UART 1 is called Serial 1 in Mission Planner. So here's UART 1, TX1 and RX1 and 5 volts and ground. So we'll just have a 4-pin connector. And the Raspberry Pi has 5 volts ground, TX and RX. So they're all right next to each other. So that's what we'll use for that. So it's also a 0.1 inch DuPont header. Now this is showing the regular Raspberry Pi, but the Raspberry Pi Zero has the same layout. So here's the mapping. And then I'll show you the picture, if I can find it here. Okay, so up until now, that DuPont connector has been disconnected. The Raspberry Pi has just been powered externally from this USB power supply. I'm going to disconnect that and then plug in the Pi connector here, and you can see it's got red, black for 5 volts and ground, and that goes to the flight controller. And then yellow and white go to TX1 and RX1 on the flight controller. So that would be then our next step is to wire it. So now it's been wired. And now I'm going to gracefully shut down the Raspberry Pi, which is on the USB connection. Now, let's let it shut down. All right. Now I'm going to plug in the... I still need to configure the drone flight controller to look for MAVLink traffic on serial 1, or it won't communicate with the Raspberry Pi. So that what I'm going to do is plug the flight controller in to the USB cable connected to the computer. And it should have made a beep beep. And we're going to go to Mission Planner. And we're going to connect with the COM port, which hopefully shows up here. Okay, here we go. I was using the wrong cable. So let's plug in the USB correct cable to the computer, to the flight controller. And we get the ding ding. So we should be able to connect with Mission Planner. COM5, great.
Mode change to stabilize.
Yeah.
Configure, Barrow, unable to initialize driver.
Oops. Now we can turn off.
Configure, fix problem then reboot. Configure, fix problem then reboot. Configure, fix problem then reboot.
Okay, there we go. So what we need to do is configure the Let's go back to the directions. So we've connected the hardware. Now we need to set the MAVLink traffic and port correctly in Mission Planner for ArduPilot. So we've connected now. Go to Configure, Full Parameter List, and we're on serial 1. Serial 1, so the baud should be 57K, protocol 2. So that's good. Disconnect. So we're done with that. And I'll unplug the USB cable. So now we're done. We've configured the flight controller for the correct port. We've configured the Raspberry Pi for the correct port. We've wired the Raspberry Pi to the flight controller, the correct connectors, and we should be good to go. So I'm going to connect the I'm going to power on the drone now. Nothing's connected to it, just the battery. There it goes. And connect with Mission Planner. So we need to know the IP address. We need to know the IP address of the drone. So the way you can do that is SSH into it. Takes a minute to boot. And you just type in, I think it's ifconfig. Yeah. So here's the IP address, 194.168.1.244. So if we go to Mission Planner, instead of COM, we're going to use TCP. And 57K baud, we're going to connect 192.168.1.244 and port 5678.
Mode change to stabilize.
So now we're connected to the drone through the Raspberry Pi Wi-Fi, which is connected to the flight controller. If I move the drone, you can see the artificial horizon change. Oops. Okay. So that worked, but we're still locally on my home local network. So let's do something more impressive. Let's disconnect that. And let's do it through ZeroTier, because you may be behind a firewall or your drone may be behind a firewall. So let's change this to my cell phone hotspot. Just to show, we can go behind the firewall to the drone. So we want my cell phone hotspot here. Galaxy S23. Connected. Let's confirm. This is the cell phone IP version 6 address. So we're on the cell phone network with my laptop. And now we need to make sure ZeroTier is connected. So let's go ZeroTier. And look and see where we're connected. It says demo. I'm going to disconnect and then reconnect because that'll force it to reconfigure the routing. It should do it automatically, but sometimes it takes a minute or more. So now we're going to reconnect to the demo ZeroTier network. And I can go to ZeroTier to confirm that I'm connected and what the virtual IP address is of the Raspberry Pi, so I can log into it with Mission Planner. Okay, so here's the demo network, and both devices are connected to the VPN network. This is the IP address of the Raspberry Pi and within the VPN network. So it should be that if I go to Mission Planner and use that IP address, same port 5678, that it'll connect. Now sometimes it takes a while for the VPN to get configured, which seems to be the case here. So let's be patient. Let's click Mission Planner. Refresh ZeroTier. Check it. It says it's connected to that demo network. Let's try Mission Planner one more time. Connect. That's the address 12.35. Let's confirm that. Yes. Confirm. Okay. Port 5678. Still not connected. So it just takes a few minutes for ZeroTier, I guess, to get configured. And the other way we can check whether ZeroTier is configured is to try to SSH into the Raspberry Pi. If we can't SSH in, that means that the network connection is not yet established. So that seems to be the case. Let's try one more time. Disconnect. Reconnect. There we go. Now I can SSH into the Pi. So now I'm SSHing into the drone from behind, from my cell phone, tethered, 4G connection through the internet, through my home router, which is a firewall, punching through that firewall with ZeroTier, connecting to the Raspberry Pi, and then connecting, hopefully, to the flight controller.
Mode change to stabilize.
So I can wiggle it, and that's how you connect to your drone from anywhere in the world using a Raspberry Pi. Obviously, we want to use the Raspberry Pi for more than just routing traffic. It can do anything you want. You can SSH into it while it's flying in the air and give it commands, receive commands. You have a full-blown Linux machine in the air that you can connect to from anywhere in the world over the internet to your drone. So that's a very powerful platform, and now we've got it all configured to connect.